Hello, sir.
Yeah, so if you have any questions, you can ask. I'll just meanwhile set up. There's some issue with this thing. Just give me a minute. Huh?
Okay, okay.
I think it's fine. Okay, so you had any questions?
Sir, actually,
Just 1 second. I'll connect the earphones.
okay.
Yes.
Sir, actually, I was asking, sir, can you refer any undergraduate book for probability, because I didn't have any undergraduate probability course in my BTech, so I am having a kind of difficulty in reading from this book, because this is so precise and everything, and also the axiomatic approach and set theoretic approach. So, can you refer any book?
Just give me a minute. I'll write it. I'll share and write it down.
Okay, sir. Okay, sir.
Just 1 minute. Huh? Courses, lecture 7. Okay, so I'll just share the screen now. Okay, can you see?
Yes, sir.
Yes, sir.
Why is this? Okay. Okay, so for undergrad level book, there is a book by John Tsitsiklis and Bertsikas. So you can ask Sumit to share that book. I had shared with him long time back. Sumit, can you share it with everyone?
Yes, sir.
Okay. Yeah. Is that fine?
Yes, sir.
Is that
Okay,
fine,
sir.
Rishabh?
Yes,
Yeah.
sir. Yes, sir.
Okay. So let's get started. Yes.
Sir, in one of the previous lectures, you have talked about conditional expectation.
Correct.
So, sir, in that, there was a calculation of probability of x1 plus x2 equals to j. Sir, in that, x1 plus x2 equals to j is equals to summation limit k equals to 1 to j minus 1. Probability of x1 equals to j minus k and into probability of x2 equals to k. Sir,
Correct.
there, j was varying from 2 to 12. Right?
I'm not sure which one are you referring to.
So it was a summation of two dices. So two.
Yeah, two dices.
Yeah, I'm not sure if it is saved. I hope it is saved. Let's look at this.
Lecture 5.
Not lecture 5. Okay. What happened? Oh my God. Why is this lecture 7? Okay, so let me just write that. So you were saying expected value of S is equal to?
Probability of x1 plus x2 equals to j.
S is equal to j given?
Not x1
No,
plus
what is the
What
question?
probability expectation of x?
Huh?
Expectation of x given s is equal to z. It was the
Okay. Probability of x1 given s is equal to
s equals
j.
to j.
Right? So this is what you are supposed to compute, right?
Yes.
Okay.
Yes.
So now, what is the question now? Do you want me to go through this again, or what is the
In
question?
that,
Huh.
about the limits. the limit of like k was from 1 to j minus 1.
Okay.
Yes, sir.
So this is x1 plus
Limit of
x2.
k
Okay. So now let's look at this. So what is, how am I going to write this? Overall k, I'll write the limits later. So this is k, right? Into probability of x1 equal to k given s is equal to j, right? This is something. You agree with this?
Yes, sir.
Huh? So now I can say, for example, k. So what is the probability that x1 is equal to 7 when k is 7? It is 0, right? Because you only have 6 sites. So this limit cannot be more than 6 for sure. So you might say that this is from 1 to 6. But the problem is if j happens to be, let's say less than, let's say j happens to be 3. That means the sum x1 plus x2 is 3, right? x1 can be 3 minus x2. So suppose x2 is 3, you will get x1 equal to 0, which is probability 0. It doesn't count towards your average, right? So now the only possibility is you can start from 2, right? You agree? That means 3 is your j, x2 can start from j minus 1, right? I mean, it can go till j minus 1. It can start from 1, right? 1, 2, that's all. So k equal to 1 to, this is what you get. Is that fine?
Sir, but summation of the two outcomes of the two dice can be 12 also. 6 and 6 comes.
But you are conditioning on the fact that it is not 12, right? J. So suppose, you are saying S is equal to 12, right? I understood what you are saying. If S is 12, I am just summing it till 11, right? That's what you are saying. The sum can be 12.
In that case, it cannot be 11.
Yeah.
So those are absurd cases for x1. So I think these cases are already excluded. Like after 6 from 7 to 12, x1 cannot take 7 to 12
Yeah.
values.
So basically, yeah. So for example, if S is 12, right? I am saying k equal to 1 to 11, right? What is, so that means k can go from 1 to 11, right? 1 to 6, of course, you can allocate non-zero probability. What about 7? Probability will be 0, right?
0.
Yeah. So it's taken care
But
of.
one more thing. Like if we calculate probability of x1 plus x2 equals to j, it came out to be j minus 1 by 36.
Okay.
Okay, so if we have 12 here, j equals to 12, then according to this formula, it will be 11 by 36, right?
No, if this is 12, right? Okay. When can this be 12? You have to have 6, 6, right? That's only one possibility. But what are the other possibilities? There are 36, right? 1 by 36 is the answer. It's 1 out of 36 possibilities.
But we calculated the formula of this probability of x1 plus x2 equals to j as j minus 1 by 36.
No, I think j minus 1 by 36. No. We didn't calculate this as j minus 1 by 36. So I said, I think probability of one of them. Okay, let me just think 1 second. What is the yeah, so probability of x equal to j given, or x equal to k given, no, that is also not the case, right? I'll just check what is it that I had written. It was in the last class, or
Lecture, sir.
Hmm?
Fifth lecture.
So last to last.
Okay, let's calculate. So what is it that you need to calculate? What was that?
x1 plus x2 equals to j.
You want to compute this, right?
Like summation.
Yeah. So probability of x1 plus x2 equal to j given x2 equal to k into probability of x2 equal to k, right? Do you agree? Hmm? So overall k, this is what we want. Do you agree? This is probability of x1 equal to j minus k, and it's independent of x2, so this will be probability of x2 equal to k, right? So now this k can go from where to where? It can go from 1 to till what?
J minus 1 is
Yeah, so it can go from 1 to j minus 1, right? J cannot be 1, okay? So this cannot be 1. If it is 1, then the probability is 0. So j can go from 2 to something, k can go from 1 to 1 less than j. Do you agree?
J minus.
Yeah.
Yes, sir.
Now, what is probability of x1 equal to j minus k? Obviously, this is less than 6, right? So, so for example, x1 equal to j minus k is, I think we have assumed equal dice, right? So 1 by 6. This will also be 1 by 6. But you have to go from k equal to 1 to j minus 1, right? So how many terms are there?
Yes, sir.
Is that correct? Or j terms are there? So let's look at this. J equal to 3, then you have 2, right? K equal to 1, k equal to 2. So this is j minus 1, right? Yeah, so that's correct. J minus 1 by 36, right? Anything wrong with this?
This is what we calculated.
Huh? So going back to your thing, so if j is 12, you are saying j is 12. Let's look at what is the mistake here.
Sir,
If
excuse me, sir.
yes.
Sir, in j minus 2 cases, the probability of x1 equals to j minus k will be 0, no, sir?
J equal to?
No, sir. We have got the result j minus 1 by 36. In that j minus 2 cases, means except one case, let's say x1 plus x2 equals to 12, sir. So that.
So this has only one possibility, right? So
1 by 36.
1 by 36. So
in
j,
the 10 cases will be probability of x1 assuming some value will be 0, no, sir? That we have not taken into account here, sir.
Probability of assuming x1 equal to
x1 equals to j minus k. So in 10 cases that probability will be 0.
Correct. So for example, if j is 12 here, right, k can go from 1 to 6. Yeah, so this is basically, this is whenever j is less than or equal to 6. Okay, if j is greater than or equal to 6, what happens? So if this is, for example, 7, right, k can go from 1 to 6, 1 to 7, 1 to 8, and so on, right? So yeah, what did I miss here? So k is from
Sir,
j.
is greater than 6, then this term will be 0, like probability of x2 equal to this k. This will become 0, sir.
This will become 0. So
Yes,
if j
it will
is
not count.
7, k cannot be. If j is 7, k can go from 1 to 6, right? No problem. Do you
Yes.
agree? K is 8. This can go from 1 to, yeah, so this is the thing, right? So yeah, okay. Okay, so I'll write this. So this, okay, if j is less than or equal to 6, right? This will be equal to k equal to, if it is k equal to 1 to 6, this thing, if j is greater than 6, right? This is what you have to get. Do you agree?
Yes, sir.
Is that correct? if you have 12, see, 1 second, I think,
So if we increase k beyond 6, then it will count only 0 only in that sum, sir.
no, it depends on what j is, right? So if j is 7, you can go till 1 to 6, right? J is 8, also you cannot go, I mean, k can go from 1 to 6, you cannot go beyond that, right?
Yes,
If
sir,
k is
obviously.
beyond 6, it will be 0, right? You cannot go beyond that. So, till 6, this is fine. Beyond 6, you have to use k equal to 1 to 6 only.
No, sir, even if we go beyond 6, then, sir, we get like a empty means event that is empty, so it will not count just, but we can do the
Yeah, but
calculation.
when you write this, you cannot just directly write j minus 1 by 36. That's the
Yes, sir,
point,
yes, sir.
right? Yeah, so you have to be careful when you write this thing, right? For example, if it is j is 12, right? What are the possibilities? So this sum is 12 given x2 is equal to k. Suppose k is less than, for example, if j is 6, 12, if k is greater than, so for example, if k is less than 6, right, this probability will be 0, right? So I cannot, okay, basically the point that I'm making is j minus 1 by 36 does not hold good for all, not true for all j, okay? For example, j equal to 12, it does not hold good. Is that fine?
Yes.
Okay, so for different j, you have to explicitly compute what this particular thing will be.
Sir, here's a j minus k has to be, sir, less than or equal to 6 because this probability of x1 is j minus k
J minus k has to be less than or
less
equal
than
to
or equal to
6,
6. So
right?
from where we
So
can
k
get
should
j
be greater than or equal to j minus 6.
6. So if we impose this condition, then I can. I think we
Wait,
can.
sorry. Yeah, so that's correct, right? So k should be greater than or equal to j minus, is that correct?
I think, sir, it will work.
Yeah. So it will be k is j greater than or equal to j minus 6. So this will be j minus 6 till what is the maximum value? X1 can be, it has to be less than, so j minus k should be greater than or equal to 1. So that means k should be less than or equal to j minus 1. So k can go from j minus 6 to j minus 1. Will this work?
So
Oh,
j
what will be
minus.
the j minus 1 minus 6 is 5, 5 plus 1 is 6. Yeah. So there are 6 terms. So this difference is 6, at most 6. Okay. Can you guys figure this out? I mean, it's conceptually straightforward, right? You have to write down different things, but otherwise this is straightforward. Do you agree?
Yes, sir, we will think
Yes,
over
sir.
it, sir.
Yeah. Think.
Okay.
Okay, let's move on. Okay, so now in today's class we will look at some basic inequalities. Okay, I used to teach this post midsem or whatever, so after several classes, but this time I thought I'll go more into Markov and so on. So let's start with the basic inequality. Okay, so the first inequality that we will look at is what is known as Markov inequality. Okay, can somebody tell me what is Markov inequality? Any idea? Okay, so I'll write it as theorem. Let x be greater than or equal to 0 be a random variable, then probability of x greater than or equal to some t, okay, so is less than or equal to expected value of x by t. Of course, t should be also greater than 0. Okay, so how do you prove this? Let's look at the proof, and then we will also look at the intuition. Okay, so I'll write it for general any random variable, both discrete as well as continuous. So what I have to do is I have to write it in terms of x dfx of x, still g integral, right? So expected value would be minus infinity to infinity. I can split this into two. I'll go from minus infinity to t x of x plus I'll go from t to infinity. Okay. Is this fine? Well, nobody cautioned me or nobody corrected me, right? It should start from 0. Why? That's because x is greater than or equal to 0. So it starts from 0 to t to infinity. Okay? Is that fine? So this is also non-negative. This is also non-negative. So if I drop the first term, I'll get this, right? T to infinity x dfx of x. Is this fine? Clear?
Yes, sir.
So this is greater than or equal to t. I'll replace x by the lower limit. Integral t to infinity dfx of x. This is nothing but t times probability of x greater than t, right? So this completes the proof because this is less than or equal to expected value of x. That gives me the Markov inequality. Is that fine? Okay, let's
So
go.
how did you write that line?
Which one?
Second last line, the inequality. T
See,
times.
x can take value from t to infinity, right? All these values till infinity, right? Now,
Yes.
if I take any value here, for example, this value will be larger than t, right? The value t is the least value that x can take. So if I substitute t for x, I can, that's the lower bound, right? It cannot be smaller than that, right? Okay, let's look at, maybe I'll give some intuition, okay? F of x, x. So how does the CDF look like? If x is a positive random variable, till 0, it is 0, right? Because x less than or equal to 0 is 0. And then it starts increasing, right? It will go towards 1, right? Maybe this is 1, right? It goes towards 1. Now I'm saying what is the probability that x is greater than t, right? That's what I'm looking at. So this is greater than t, right? I'm looking at the area under the curve. Okay, so now let's look at the complementary CDF. Okay, so what is complementary CDF? 1 minus this. How does 1 minus this looks like? Or I'll plot probability of x greater than t. Okay, how does it look like? It looks like this, right? For t equal to 0, it starts at 1 because probability of x greater than 0 is 1, right? And then as t increases, the events become smaller and smaller and contained within the previous event. Therefore, it should decrease, right? So this is how it will be. Okay? And eventually it will go down to 0. Now, if I want to compute probability of x greater than, let me call this as x greater than small x, and this is x. Now, I'll take it t. Okay? So now, x greater than or equal to probability of x greater than or equal to x t is this, right? So this value will be probability of x greater than equal to t, right? Do you agree?
Yes, sir.
Now, if you look at this area, what is the area of this? Area is probability of x greater than or equal to t, right?
Yes, sir.
Do you agree? What will be the area of this thing, the entire curve? So, t into probability of x greater than or equal to t is definitely smaller than integral from 0 to infinity probability of x greater than or equal to x dx. Can you recognize what this is?
Expectation.
Yeah, expected value of x. This is what we are saying. Is this fine?
Yes, sir.
Okay. Okay, so now let's look at the second one. It's called Chebyshev inequality. Okay. So let's modify this a little bit. So you have x random variable, any random variable. Okay. So it need not be non-negative. And let's say the expected value of x is finite. So you have this finite expected value, and the variance of expected value, which is defined as expected value of x minus expected value of x whole squared, is also finite. Okay, let's assume that. Now, let's look at the following. So probability, okay, let me write this, x minus expected value of x. Okay. Now, I can take the square of this, right? This is let me call this random variable as y. What can you say about y? Definitely positive, right? So this greater than t, for example, okay? Now I can apply Markov, right? Because it's a positive random variable. Expected value of x minus expected value of x whole squared divided by t. Is that fine? This is true for all t greater than 0. Okay, so what is this saying? This is saying probability of x minus expected value of x whole squared greater than t is less than or equal to the variance squared divided by t. Okay, is this fine?
Yes, sir.
Okay. I can do some
So why did we take such a random value like x minus ex whole square? I mean, why do you take it?
so for example, what will this give us? Expected value of x minus expected value of x.
Mean
When you do the
deviation.
random experiment, it tells you the deviation from the mean, right?
Yes, sir. Yes, sir.
Square gives you the another measure of deviation from the mean. Typically, the power, energy, and all that depends on square, right? So it's the squared error or squared deviation. I'm asking what is the probability that the square deviation exceeds a threshold t? That is upper bounded by the variance. So let's look at this. So let's substitute t equals 2 times the standard deviation. Okay, what will happen to this? Sigma x squared by 2 sigma x squared half.
Half.
Right? Do you agree? Okay. Okay, so I can also, before this, I'll just write it in a slightly different fashion. I'll take absolute value. Okay, so this gives me the true deviation, right? Okay, this gives me the deviation of x from the mean, absolute deviation being more than t. So this is same as, I can square on both sides and apply what? Markov, right? So let me write this in detail. So probability of deviation, the absolute deviation, being greater than t is less than or equal to variance divided by t squared. Okay. Now suppose I take t to be sigma x. What will happen to this? This will be 1, right? If I take t to be 2 sigma x, that means my sample deviates from the mean by an amount twice the variance, the spread, right? What will happen to this? It will be 1 by, so sigma x squared by 4 sigma x squared, so it will be 1 by 4, right? The chances will be 25%, right? Okay, let's look at this. If it is 3 sigma x, 3 times the variance, what will happen to this?
1 by 9.
1 by 9, right? So as you look at the chances of my sample deviating from the mean by an amount, let's say k times the variance, the k times the standard deviation, sigma x, this will vary by 1 by k squared. Okay, that means the chances of my sample deviating from the variance goes down significantly. Okay, as you move away from the variance. So that gives you a measure of spread, right? For example, if you look at usual Gaussian,
So this holds for every distribution, right?
irrespective of everything, yeah,
Okay.
doesn't matter. That's why we assume variance to be finite and the mean to be finite. If the variance itself is infinity, this does not hold good. Okay, fine.
Hello, sir.
Yes.
Yes.
Sir, so here x need not be positive random variable.
X need not be positive because I'm taking the
Why it is
absolute. I'm taking the absolute value. It's positive, right? So we call this as y. Okay. So y is positive. So I'll call this as y. Y is positive. I'm saying y greater than t. That's same as y square greater than t squared if y is non-negative. Right?
Yes, sir.
Is that okay? Yeah. So Chebyshev, this is called Chebyshev's inequality. It doesn't tell you much in the sense, conceptually it says something, right? It says, you know, my deviation from the mean is bounded by the variance, right? The spread. Okay. So if the spread is less, then my deviation from the mean will also be less, right? For example, if the mean is 0, if the spread is measured by sigma x, if the spread is less, for example, if it is my distribution is really skewed like this, the spread is less, the chances of me deviating from 0 is also less, the chances is less. Okay. So the point here is that you know, you are only considering the fact that the variance is finite and you are not using any other information about the distribution, right? For example, you could have used the fourth moment, third moment, fifth moment, and so on, right? One can generalize this also, right? So I can do the following: probability of x minus expected value of x greater than t. I can do the same thing, right? So probability of mod of x, expected value of x power k is greater than t power k, right? This I can apply Markov, which is expected value of absolute value of expected value of x whole power k divided by t power k. Simple Markov. But I'm free to choose k, right? I'll choose k in such a way that this is very tight, right? Okay. So this gives me another bound, right? So which is in terms of the kth moment, central moment of the random variable x. In fact, kth absolute central moment. If k is even, then it's the kth central moment. Okay. This takes into account all the moments, but the problem is computing this is difficult. Okay. So computing this is difficult. Well, not in all cases. For example, Gaussian, you know, there is a nice expression, but other cases it may not be true. Okay? Yes.
So here you have written probability of x minus expectation of x greater than t equals to the probability of that thing.
Yes.
So this equality will always be equal only.
Yes, right. So if 3 is greater than 1, implies 3 power k is greater than 1 power k, right? For all k greater than 0.
Okay, sir.
Yeah. Both are same, right? So if they are positive, if it is negative, then this is not true. If there is no absolute value here, then it is not true. Okay. So one way of encoding all the moments is to look at, for example, the exponential, right? So exponential has, for example, let's look at e power x. So e power x is what? 1 plus x squared by 2 factorial plus x squared by 3 factorial and so on, right? It has all squared, cube and so on, right? So now when you take the expected value, it takes into account all the moments and I can adjust those moments. So that leads to the third inequality called Chernoff bound. Okay, Chernoff bounds. Now, you take any random variable, let x be any random variable, then let's look at the following. Okay, so I take probability of x greater than let's say epsilon. Okay, so I want this to be, or small y or small x, okay, whatever it is, right? So small x. Now I cannot apply Markov or any other inequality because this is any random variable, right? It can be negative also. So I can do the following, right? So this is true. Do you agree? Exponentiation is an invertible function, right? If e power rx is greater than e power rx, then rx is greater than r small x, right? Therefore, capital X is greater than small x. Now, for this, I can apply Markov because this is always greater than 0. So it will be expected value of e power rx divided by e power r small x. What is this, by the way? In our definition, this is gx of r, the moment, right? Do you agree?
So it is moment when you put r equal to 0, right? Otherwise, it's a moment generating function.
Sorry, moment generating function. I meant MGF. Okay. Is this fine?
Yes.
Okay. Yeah. So whenever for different values of r, well, this r should be carefully chosen because you should choose r in such a way that this moment generating function exists. Okay. So in fact, I want to choose r to be positive. Okay. I cannot choose r to be negative. Then the inequality will reverse. Right? If r is positive, then I can write this, provided the moment generating function exists. So when will the moment generating function exist? R should belong to, what was the notation? We use some
R,
notation, right?
R plus union R minus.
No, it's r. It's from 0. Well, it should belong to r plus of x. Right? Then this particular thing exists, right? Now I can do one more thing. I can write, for example, probability of x greater than x is less than or equal to, well, I'll write it in slightly different fashion. I'll pull e power rx to the numerator, okay? And now I'll say, for example, gx of r, and I'm free to choose r. I'll choose r in such a way that r belongs to r plus of x. Okay. This gives me the tight bound. This is called the Chernoff bound. Okay. Now I can choose r to be negative also. So in that case, probability of x less than or equal to x, okay, will be less than or equal to infimum or all belonging to r minus of x e power minus rx small x gx of r. I get the same thing. Okay. Note the difference. This is less than or equal to, this is greater than x. Is this fine? Okay. Now I can write this in a slightly different fashion. Okay. So I'll take the first one, this one.
This is done just by changing the sign of r.
Exactly. Yeah.
Okay.
If I take it negative, then if I multiply, for example, 2 is greater than 1, but minus, if I multiply by minus 1 on both sides, it will become minus 2 and minus 1. So minus 2 is less than minus 1. The inequality will reverse, right? So now I can write this as infimum over all r belonging to r plus of x. Okay. I will do the following. Okay. So exponential of, okay, I can write this as e power ln of gx of r, right? Ln and exponential will cancel. So I'll have ln of gx of r minus rx, right? Okay.
Yes, sir.
So I can x minus ln of, I'm just taking minus outside. So if I'm taking infimum or all exponential of negative, I should take, so this will be less than or this will be, yeah. So probability of x less than or equal to x is less than or equal to exponential of minus supremum over all r belonging to r plus x of rx minus ln of gx of r. Okay, I can write this. Do you agree?
Probability of x is greater than x, no, sir?
I'm sorry. Yeah, you are right. Thank you. Okay.
It is
So,
also in the previous line or only in this line?
oh, no, this line only, because previous line I'm considering this, right? This inequality. So that should be this. Okay. Is this fine?
Yes, sir.
Okay. Or I can write the entire thing as infimum over all r ln of gx of r minus rx. I can also write this way. Do you agree?
Yes, sir. We are just changing this infimum and supremum, playing over negative side.
Yeah, that's all. Nothing much. This is called the exponent. Okay, so this is the exponent of this probability. Okay. So why is this quite useful? Let's look at through an example. Okay. So is that fine? Shall we look at an example?
Yes, sir.
Okay. So let's look at an example and then try to understand how one can apply Chernoff. So let's say X is binary, meaning it's binary, Bernoulli. Well, I'll just write it as this way. Okay, Bernoulli with P. That means what? The probability of X equal to 1 is P. Probability that of X equal to 0 is 1 minus P. That is what we have. Okay, Q I'll define it as 1 minus P. Okay. And now I'll look at the sum. Okay. Well, what I'm going to do is I'm going to just write this as xi and say IID, meaning I'm going to sample each time I throw a dice, I'll get the corresponding random variable. For example, the first time I throw a dice, sorry, toss a coin, I'll get x1. The second one corresponds to x2 and so on. Okay. What is this? This is the sum. Okay, Sn. For example, I can think of it as like this. I'm standing at the origin, I toss. If it is head, I'm going to move to the right by 1 meter. If it is tail, I'll stay there. Again, I'll toss. I'm going to move to the right by 1 meter, otherwise I'm going to stay there, and so on. So Sn will give me the distance from the origin to the current position. That's what it says. Okay. Now, I want, so let's also assume that you know what P tilde is, right? What is P tilde?
N into K. K by N, sorry.
K by N, right? So this is the relative frequency, right? Okay, so now let's look at P tilde into N is K, right? So the number of heads, for example. Okay, now I want to compute this probability that the sum is greater than P tilde N, right? Which makes sense, right? So P tilde N would be roughly K. So K is the number of heads, right? For, of course, I'll assume P tilde to be greater than P. Okay, so some P tilde. Is that fine?
Sir, sum cannot exceed the total number of heads, right? Because we get a head, then only we move.
Correct. So Sn is of the order of, okay, so let me put it this way. So Sn is the sum, okay? K and N are some numbers. N is the number of times I'm going to toss the coin. K is some number, okay? So some number. Perhaps can depend on N, so some number, okay?
Some number less than K, less than N, right?
Less than N, yeah. Okay? Some number less than N. Is that fine?
Yes, sir.
Now, what is it that I have to do now? So I have to apply Chernoff, right? So if I have to apply Chernoff, what will be the thing that I have to compute? I have to compute ln of gx of r minus r times not x p tilde n, right? Do you agree?
Yes, sir.
Okay, is that fine? Yeah. So let's write this. What will happen to this thing? So what is the notation that I have used? It's gx of r. Let's look at g Sn of r. What is this? This is expected value of e to the r Sn.
Yes, sir.
This is nothing but expected value of product I equal to 1 to n e to the power r xi. Do you agree?
Yes.
Agreed, right? What is this? Xi's are IID, so exponential of product is product of exponentials. So you get product, right? I equal to 1 to n, expected value of e to the power r xi. Fine. This is nothing but expected value of e to the rx1 whole power n, because expected value of rxi is same as rx1, rx2, whatever, right? It doesn't matter. Is that fine?
Yes, sir.
Okay. Yeah. Now, how do we compute this? Ln of this. Ln of this will be what? It will be n times ln of exponential of rxi, right? Rx1. Do you agree?
Yes, sir.
Okay. So now it turns out I'll leave this as an exercise that, okay, I think it's yeah, so ln of gsn of r minus, this is r times x, right? So r times x is
R P tilde n.
okay, just let me just give me 1 minute. So I'll just do one thing. So I'll just do a small change here. How do I put it? Okay, I'll just pull this n here. Okay, it is, I'll do 1 by n Sn. That's the average. Okay, greater than or equal to Pn. Is that fine? So gsn, I won't do Sn, I'll do Sn by n. Okay, is that okay?
Yes, sir.
Okay, sir.
Everything will be divided by n here. Okay, so now Sn by n minus, what happens to this minus, I'm looking at this term, right? R times x, right? R is your variable, x is your this thing. Now what is x here? Of course R times, what is x?
P tilde.
X is not p tilde n, it's p tilde, right?
Yes, sir. P tilde only.
Okay, so this I have to take infimum over all r greater than or equal to 0, right? That's what we have. Okay, this, okay, so when you of course I have to maximize or minimize this function over all r. Okay, that's what you have to do. Okay, so this results in the following. So p e power r divided by q plus p e power r is equal to p tilde. Okay, so rearranging, what do we get? So we get e power r is equal to p tilde q divided by p times q tilde. So well, q tilde is 1 minus p tilde. Okay, this is what you get. Okay, so now I can write this whole thing, right? So whole thing in the following way. So it's p tilde, when I substitute for r, for example, I can take r is nothing but, so this implies r star, the optimal would be ln of p tilde cube by p q tilde. Okay, this is what we have. Once you substitute it here, you will get the following. So p tilde ln of p divided by p tilde plus q tilde ln of q tilde by q. Okay, so what is this called?
Kullback distance
Between
p tilde and p.
p tilde and
P.
p, right? So this is nothing but the Kullback-Leibler distance between p tilde and p. We saw this, right? Okay. Now we have the exponent. So what will be the answer? Final answer. So probability of Sn greater than or equal to p tilde n is less than or equal to, this is the exponent, right? This is the exponential of, well, remember, it will be 1 over n. Okay, so it turns out that there is a n times the Kullback-Leibler distance between this and this. Okay, did I miss an n somewhere? Yeah, I think I missed an n somewhere. Okay, so I think yeah, so I think somewhere check this. Okay, so check where I have missed an n. Okay, so this is what you get. This is exponential of minus n times p tilde and p. So in other words, if these two are close, right, what do we get? Well, this is almost, for example, if p tilde is exactly equal to p, dp tilde p is 0, so you get 1, right? So you get a trivial bound. On the other hand, if p tilde is far from p, then dp tilde p, Kullback-Leibler distance, is large, in which case, as n increases, this goes exponentially down to 0, and therefore this probability goes down to 0 exponentially fast. Is that fine?
Yes, sir.
This is one bound. In fact, if you look at the in one of the classes, we looked at a bound on this, where I had written something like square root of 1 by 2 pi n p tilde q tilde and so on, right? Exponential of minus n times Kullback-Leibler distance. Of course, that you can get provided you do some binomial approximation, basically Stirling's approximation. I think it's one of the exercise problems that you have supposed to solve. Okay, so again, it turns out we will I'll leave this as a homework. I'll give you this as a homework with hints. It turns out that if you take limit, okay, so I'll do the following. I'll take log of probability. Okay, this is log of course, natural logarithm, and I'll scale it by n. I mean, I'll just divide by n and take limit n tending to infinity. So it turns out that this is nothing but the negative of the Kullback-Leibler distance between the two, where p tilde is greater than p. Okay, so that means the exponent of this probability is Kullback-Leibler distance. That means you have to prove upper and lower bound to show this. Upper bound and lower bound both exponentially falls down to 0 with the rate given by Kullback-Leibler distance. Is that okay? Any questions? I mean, questions? Yes.
Sir, just above, sir. Yeah, this p tilde, sir. How you write this p tilde is equal to something? This expression. Sir, just little down, sir. This one, sir. Expression for the p tilde is p e to the power r over q plus p to the power r, sir.
Where is that? Sorry.
Sir, just yeah. Sir. P tilde is equal to, sir, this p to the power r q plus p to the power r.
This one you are talking about, right?
Yes, sir.
Huh?
Yes, sir.
So this, for example, I have to solve for this equation, right?
So,
In other
sir,
words, I have to optimize this with respect to R.
so, sir,
So how do you do that? Well, you have to compute this. What is this? This is summation over all x, of course, from 0 to 1, x e power rx by n, right? That's what you have. This is nothing but x equal to 0, then you have, of course, 0. 1, what do we have? E power r by n whole power n, right? So that's what we have, right? Do you agree? So we can use that to write the remaining. Is that fine?
yes, sir.
Okay.
Sir, this infimum can be, how can you calculate this infimum, sir? Just by using that calculus and also, like,
Yes.
suppose it is a function of r, then we just try to minimize this one.
So when you write this explicitly, you will see the form of the graph. Okay, you can write this as a function of r. Okay, so this will be something like this. I don't know whether it will start. Yeah, so it will be like this. The minima is this point. It's continuous, differentiable everywhere, and you take the derivative and equate it to 0. You'll get the global minima because it is convex. Okay. Yeah. So that's how you do it. Okay. If you don't get it, let me know. I'll repeat it. I'll do this exercise. So this particular thing, I think last time I did it right, Savan.
Sir, yeah,
Did I do this or not?
not
Okay.
sure, sir.
Okay. Let's look at this, right? So what is okay? So probability of Sn. Okay. So Sn by is greater than some n times some p. Okay. So this is what we will do. So what is this? This is if you apply Chernoff, this will be exponential of ln of GSN of R minus RNP, right? So what is GSN of R? This is expected value of e to the power.
Will be there, no, sir?
Oh, yeah, so there is an infimum. Actually, yeah, there will be an infimum overall here. Okay, so let's quickly do this. So what is this? This is exponential of R times, right? The summation, right? Summation xi. This is nothing but will be product. Product will be exponential of e to the power rx1 whole power n, right? So this is nothing but e to the power r n. Do you agree? Is that correct or no? So no, wait. What is this? This is summation overall e to the power rx into probability that x equal to x, x1 equal to x equal to 0 and 1 whole power r, right? So whenever x equal to 0, you have 1 here, and this will be 1 minus p. Whenever x equal to 1, you have e power r, right? Probability will be p, right? Whole power n,
Yes.
right? So now what do we have? So we have 1 minus p times 1 minus e power r whole power.
Yeah.
Do you agree? So
Yes.
the assumption here is that, of course, r is positive. So what will happen to this term here if r is positive? R greater than 0, right? That's what we want. If r is greater than 0, this will be e power r will be greater than 1. So this will be negative, and therefore this will be, so I can write this as 1 plus p into e power r minus 1 whole power. Okay?
Yes, sir.
Is this fine? So this is less than exponential of np e power r minus 1. Okay, I can do that. 1 plus
L.
x is less than or equal to e power x, right? I hope this will work. I'll try. Okay, so this is what we have. The other term is minus r and p. So I have to take the log of this, right? Ln of this. So I'll have np e power r minus 1 minus R and P, right? Okay. So I have to take the derivative. I have to take the infimum over all R of this.
Yes.
Right? Let's blindly take the derivative. You get e power R minus R will be NP equal to 0. E power R is, hey, did I make a mistake?
1.
I think I made a mistake here. What is the mistake? Hey, did I make a mistake? Hey, okay, fine. This is fine. E power Rx. So whenever x equal to 0, you have 1. Probability of x equal to 0 is 1 minus p plus this will be e power R times p. Okay, so this is 1 minus p times 1 minus r e power r p times e power r minus 1. Okay, so this is e power r minus 1. Okay.
So how do you write that line?
Which
that,
one?
Less than equal to exponential in p to the power r minus 1.
1 plus x is less than or equal to e power x, right? Obviously,
Okay,
it's a very loose bound. But
okay. In to the power n. Okay.
Okay, there's something wrong with this approach.
Here we get R equal to 0.
Well, r equal to 0 will give me no. Wait. No, I don't think you should. Okay, so there is something going on here. So some mistake I have done. Okay. Anyway, so next class I'll do this. Okay. I'll do this. Savan, you were saying something. Did I do this in the last previous class? I mean previous last year course.
No, sir, I don't remember this one.
Okay, so I'll do this. Okay, so I'll continue with this in the next class and complete this. Okay. Somewhere I goofed up in between.
Yes, sir, one more thing from the last class, sir, that you have given the x1 and x2 are the IID, then f of x1 and g of x2 is IID, no, sir? So by proving, sir, IID, we have to show that they are independent.
Oh, sorry, it's not okay. Did I say IID? You just prove that it's independent. Okay, it need not be IID.
Yeah, IID is.
So sorry, no, it should be independent. That's all. IID not possible, right?
Okay.
X1, X2 are Bernoulli. Okay. X1 squared and X2 plus 1 both are Bernoulli and identically distributed also. But X1 squared and X2 plus 1 are independent but not identically distributed. Okay, you should keep that difference. Okay, yeah, okay. So we'll meet in the next class. I have another meeting now, so I'll end the class here. We will sync up again. If you have any questions, just drop in an email.